Dhanasekaran, Assistant Professor, Department of ECE. In this video, we going to see digital logic design, that is flip-flop from digital logic design. Okay, so these are the outline of our PPT. First, we going to see what are sequential circuits. Then we going to discuss types of flip-flop. So before going to see the flip-flop, we have to know what is combinational circuit and what is sequential circuit. So combinational circuit, the output only depends upon the input, whereas in the sequential circuit, the output of the circuit depends on the previous output and the present input. Okay, and the input must follow the specific sequence to produce a required output. In order to follow a sequence of input, the circuit must contain some form of memory to or retain knowledge of those inputs. In sequential circuits, we have a combination logic circuit and memory element. The input it's going to obtained in the combinational logic circuit, then it gives some output. Again, the output is feedback to the memory element. From the memory element, it gives to the combinational circuit. So this works, that this functions routine, it will happen in the routine work. Okay. The memory are obtained by the feedback connection, and the most sequential systems are based on the small number of simple sequential circuit elements. It is called the flip-flop. So what is flip-flop? So what is flip-flop? Flip-flop, it is a sequential circuit, an electronic circuit which has two stable states, and there is capable of storing as one bit data. Bit, it may be a 0 or it may be a 1. Okay. So what are the applications of flip-flops? Where it is used? So application of flip-flop is it is used in the counter and voltage divider, shift register, storage elements. So these are some of the applications of flip-flops. So here we going to store one bit. That's why flip-flops are used, and this is one of the sequential circuit, and it has two stable states. So there is a capable of storing a bit. So we can store one bit in this flip-flop. So these are the introduction of flip-flops. So we have input, and we have normal output and inverted output. That is normal output is Q and inverted output is Q bar. And there are high and low inputs are we going to give in the flip-flop. Whenever we refer to the state of flip-flop, we refer to the state its normal output. So in this more complicated flip-flop, we use the clock as a control input. So these clocked flip-flop are whenever the input and output signals must occur within the particular sequence. So they have two stable conditions and can be switched from one other two by appropriate inputs, and these stable conditions are usually called states of circuit. So these are the types of flip-flop, and first and latch. So we have a latch, SR latch, clocked SR flip-flop, JK flip-flop, and D flip-flop, T flip-flop, master slave JK flip-flop. So we should know the difference between the latch and flip-flop. So what is latch? So here in this flip-flop or latch, we should trigger for its running. Okay. So flip-flop is that is we have a triggering, different types of triggering, that is a positive triggering, negative triggering, and edge triggering and level triggering. So flip-flop are a level triggering, and latches are sorry flip-flops are edge triggering, and latches are level triggering. Okay, so we going to trigger latches and flip-flop. That's a difference. If it is an edge triggering means flip-flop, and level triggering means that is latch. Okay, so these are the difference between the flip-flop latch, two basic building blocks of sequential circuit, but there is a suitable difference between these two. Is the flip-flop continuously checks the inputs, and the corresponding changes its output only at the time determined by the clocking the signal. Whereas the latch is a device which continuously checks all its input and correspondingly changes its output. So independent of time determined by the clock signal. So here you know the difference. Okay. So these are the latch, and we have a S and R and Q Bar. So S and R is the input, and Q and Q bar we get output. So this is a basic SR latch is an asynchronous device. In this asynchronous device, the output is immediately changed anytime one or more of input changes, just a combination of logic circuit. So it does not operate in step with the clock or timing. So these are the logic diagram of this is the logic diagram of SR latch, and we have a input 0, 0, 0, 0, 1, 1, 0, and 1, 1. We got in this Q 1, 1 and 0 Q, and 1, 0 and 1 Q bar. So for 0, 0 input we'll get invalid output. For 0, 1 input we can set that as a 1 output from the Q bar. For 1, 0 input we'll get a reset function. For 1, 1 that is a hold function. So that is no change. Whatever the input we get in the SR, we can get the same input in the output side. So that is a SR latch, and this is the SR latch timing diagram. So here we know that whereas a level here, yeah, as I already said, these are the level triggering, that is latches are level triggering. Okay, here you can see the level triggering, that is S and R, the positive level, and Q whenever it will get positive, the Q it will give a positive, same like as Q bar also. And this one is a clocked SR flip flop. Here the difference is we going to use clock in the circuit. The additional clock input is added to the change the SR latch from element used in the asynchronous sequential circuit to one which can be used in the synchronous. It means that flip flop can change the output states only when the clock signal make a transition. Okay, and this is a clocked SR flip flop. As you know that we here are going to give a clock in between S and R, and the output is different. Whenever S is 1 means it will set, whenever the R is 1 means it will reset. That's the function. And this is a SR clocked SR flip flop timing diagram. You know that flip flop is edge degree. Whenever the edge gets positive, and it will trigger. Okay, and JK flip flop, in this JK flip flop we have a J and K input and Q and Q bar output. Another this is one of the another one flip flop in the JK flip flop. It's a difference from the SR flip flop. When J K is equal to 1, condition is not intermediate, but it's defined to give a very useful changeover, that is a toggle action. You know the toggle actions? Toggle means that Q and Q bar will switch to their opposite states. If it is a Q is 1, the Q bar will be a 0. If it is a Q is a 0, the Q bar will be definitely 1. So that is the toggle operation. The JK flip flop has a clock input and two control inputs, J and K. Operation of JK flip flop is completely described by a truth table in the figure. We have it. See, this is the truth table of JK flip flop. So whenever J will get 1, that will set. Whenever K is equal to 1, that will the output will be reset. Whenever the both input is 1, the output will be toggle. Okay, so whenever J and K is equal to 0, the output the status will be the hold function. Okay, this is a logic diagram of JK flip flop. And here we should know about race around condition. As we know that during the high clock whenever applied, the changes, the output also change, that is the input changes also changes in the output. Okay, but the JK flip flop, K is equal to J and K is equal to 1, without any changes the input, the output changes. This condition is called a race around condition. So this is the timing diagram of JK flip flop, and we can see the toggling timing diagram, that's a Q and Q bar. Okay, so that is doubling. Whenever Q is high and Q bar is low, whenever the Q bar is low, sorry, Q is low, Q bar is high, that is a toggling function. And this is a D flip flop, and it can be constructed from the SR flip flop JK by additioning of inverters. We just adding inverter here in between the J and K. The inverter is connected so that the R input is always inverse of S. So or it may we can say that the J input is always completely complementary of K. In this D flip flop, it will act as a storage element for a single binary digit. And this is the logic diagram for D flip flop, and this is a truth table for D flip flop. Here, whenever D is equal to 0, it will status it will be reset. Whenever D will give a 1, it will set. So what is the meaning? If you give a 0 to the D, you can get a 0 output in the Q. If you give a 0 to the 1, you can get 0 to the 1 to the Q. So in terms of Q bar, it will toggling the output. Whatever the Q, the complementary output we can get in the Q bar. So this is a T flip flop, and the T flip flops has only the toggle and hold operation. If toggle mode operation, the output will toggle from 1 to 0, vice versa. Okay, this is the logic diagram, and this is the Q. Whenever the T is equal to 0, it will the status is hold. Whenever the T is equal to 1, it will toggle. Okay, so that is T is equal to 0 means Q is equal to Q. T is equal to 1 means that is a Q bar. Okay, and the last one is the master slave JK flip flop. The master slave JK flip flop is designed using two separate flip flops. Out of these, the one act as a master and other one as a slave. The output of the master JK flip flop fed to the input of this JK flip flop. The output of the slave JK flip flop is given to feedback to the input of the master JK flip flop. The clock pulse is given to the master JK flip flop and it's sent to the NOT gate and thus inverted before passing into the slave. Whenever master flip flop output that is going to inverted, then it will give to the clock of the slave flip flop. If it is a master flip flop, clock is 1 means that is positive means it will inverted, that is negative is going to give the slave. So these are the applications of flip flop. As I said, it's a register, frequency divider, digital counter, and shift register. There are as I already said, there are so many applications in the flip flop, and this is the conclusion. And the flip flop and the basic memory element which is store 1 bit at a time, and we have to state the state and reset. There are different types of flip flops as we saw in the this video, and the number of inputs and the way inputs are given and define the flip flop types of flip flop. Okay, so these are the reference book, and thank you for watching video.